Patel. I'm going to teach you today on the topic called as dynamic programming. So in dynamic programming, to solve the dynamic programming, you can solve that uh, problem in the way of the recursion. So recursion is the one of the way to solve that problem. But in the recursion, it gives the larger time complexity. You may be heard about the time complexity and space complexity. So there are two methods to solve the particular questions for the dynamic programming using the memoization and the tabulation. So in the memoization, you your approach to the problem is like top down, and in the tabulation, your approach to the problem is bottom up. So we are going to let's learn about the dynamic programming using the real examples which were asked in the coding. Okay, so there is one example. So you maybe heard about the Fibonacci number. So it is a very popular problem for the dynamic programming. And today we are going to discuss how we can use this Fibonacci number problem using the dynamic programming. So I will give the introduction about the what is the Fibonacci numbers are. So so for the first Fibonacci number is 0, second Fibonacci number is 1, the third is 1, the fourth is 2, then 3, then 5, then 8, then 13, and it goes on. Okay, so maybe you noticed about the like, so for the whatever the number, like the how we can calculate the second number is the addition of the first number and the second number, which is the uh, value of the third number. So similarly for the fourth number, is it is the addition of the third number and the second number. And similarly for the fifth number, how we get the 3, it is a 2 plus 1. Okay, and similarly for the next numbers. So if you got means, so what will the example like? So when you need to find out the 100th Fibonacci number. So how you can do that, right? So you can write into the like these list till the 100, but it will time confusing. Okay, so we can solve this problem using the Fibonacci number. So maybe you can solve this 100th Fibonacci number you can get with the addition of that list and so on. But how you can find out the 1000 or 10,000th Fibonacci number? So for that, we need to write the code. And how we can write the code, we are going to discuss now. So the first approach to solve this problem is like a recursion. So you maybe know about the recursion. So recursion has the one base case, then there is a recursive case, yeah, and then means through that we are getting the result. So what will be the base case over here? So while solving the problem, means while saying the problem, I said that like the first Fibonacci number is 0, then the second Fibonacci number is the 1. So you can think about like, so this is the base case, like the first or the zeroth Fibonacci number is 0, and the 1th Fibonacci number is 1. Okay, so how we can find out the, so we are going to discuss like the recursive function, recursive case for this Fibonacci number. So how we can find out that? So what means, I have already just told you that if you want to get any number, let's say 13 here, so it is addition of the 8 and 5. So let's say this is the fifth number. Okay, so how we can find out that it is addition of the fourth number and addition of the third number. Okay, so how we can write it in the recursive case? So it is like function of fn is equal to f of n minus 1 plus f of n minus 2. Okay, and what will be the base case? Like it is if n is less than or equal to 1, right? So we can just return the n, right? And this is the recursive function case. So yeah, let's write the code for this Fibonacci number. Okay, so the return type is the integer, and we are going to find out. So we are going to set it as integer n to the number, and so if n is less than or equal to 1, we can return the n. So this is our base case. Okay, and for the recursive case, we can do like f of n is equal to f of n minus 1 plus f of n minus 2. So this will be like, you can solve, let's say, if I have sent the Fibonacci of 100, it will give me the result. And similarly, for the Fibonacci of 1000 or 10,000, it may give you the time limit exceeded as a result, because it will take a lot of time to do that. So let's find out the what will be the time complexity for this one, or the recursive tree for this one. Okay, so for the time complexity, we will consider like we need to find out f of 5. Okay, so how we can going to find out this f of 5 is like, so it is a summation of f of 4 and f of 3. Okay, so whenever the recursive call gets run, so it will first run the left side of the recursive call. So I'll just write the left side of the recursive call. So how we can calculate the f of 4? That is f of 3 and the f of 2. And how we are going to call the f of 3 is like f of 2 plus f of 1. Okay, and how we are going to calculate the f of 2 is f of 1 and f of 0. And these f of 1 is our base case, f of 1 and f of 0. So if you go to this, so here, this is our base case if n is less than or equal to 1. So whenever you will get the base case, it will directly return the whatever the output for that. So here it will return 1 and here it will return 0. And how, what will, so then what will be the value of f of 2? It is 1 plus 0, f of 1 plus f of 0, which is 1, right? Here f of 1 is also a base case. So what it will, right? So its value is 1, and addition of both of these is the value of 2. So f of 3 has the value 2. Okay, so yeah, you might be saying that I have just written only these trees. So for the f of 2, similar tree will be there here, right? Like for the f of, so f of 2 is addition of f of 1 plus f of 0, right? So similar tree, and similarly it will give this result as a 1. Then f of 4 will give as a result as a 3. And here f of 3 is there. So similar, this similar tree will be there for the f of 3. So we have the f of 2 plus f of 1. And similarly for the f of 2, it is f of 1 with f of 0. Actually, I'm using the mouse, so you can bear with my handwriting. So this is will be, so f of 1 and f of 0 is base case. So f of 1 is 1, f of 0 is 0. So f of 2 will be the 1, f of 1 is 1. So f of 3 will be 2, and then 3 plus 2 is 5. So whatever f of 5, you will get the answer for the 5, right? So you can imagine, like, if you have the larger number like hundred thousands like that, so for that is this tree will be larger in that case. And if you can see over here, right, we are calculating f of 2 3 times, right, repetitive times. Okay, f of 3 also we are calculating repetitive times. Yeah, so these we can avoid, right? How we can avoid? It is a memoization. Okay, so how we can avoid it? Through like memoization, we can create an array. Okay, let's say I have this array. So it is initially initialized with the -1. So this is 0th index, 1th index, 2th index, 3rd index, 4, and 5. So currently I have considered the array size will be like the whatever the input number, like f of 5 plus 1. So it is size of a 6. Okay, so whatever the result will be here, that will be the answer. So we can initialize first it with -1. Okay, so if you can see, like, so whenever this tree goes on that, if we found any answer, then we can update this array. Let's call it as a DP array. Okay, so let's say, yeah, we again go through this tree. So f of 5 is addition of f of 4 plus f of 3. F of 4 is addition of f of 3 plus f of 2. Then it will go to the f of 3 is addition of f of 2 and f of 1. And f of 2 is addition of f of 1 and f of 0. So now we are here to the base case. So f of 0, what it will return? It will return 0. Okay, so I'm going to change this with the value 0. Okay, similarly for this f of 1, it will return the 1. So again, I'm going to change this value to 1. Okay, okay, then we get the, so with the use of f of 1, f of 0, it will get the output for the f of 2. So what will be the f of 2? 1 plus 0. That will be value 1. Okay, so similarly for the f of 3, we will get the answer. Like we can insert it as a 2 with the output. And how we can find out f of 3? We already got the f of 2, which is 1. And what will be the f of 1? It is, we already got the 1 as the output. So we are adding the 1 plus 1, which is 2 over here. And for the f of 2, again we are going to, in this tree, no, because we have already value of the f of 2, which is 1. So now it's 2 plus 1, which will be the 3 for the f of 4 answer, right? And similarly, for the f of 3, this value, we already have its value as a 2. So we are not going below this tree. So we will get the answer as a 5 for the this array, and just we will return output as a 5. Okay, so here we are not visiting the each of the uh, means whatever we have already answer for that, we are not uh, visiting that node. So if you consider the recursive function, then it will give some. So if you check the edges of these things, so it will almost like 2 raised to n, almost, not will be the exact, but it is the almost. So this is the time complexity for the recursive function. Okay, and if you check for the this memoization technique, we are only calling f of 5, f of 4, then f of 3, then f of 2, then f of 1 and f of 0, right, which is the base case, and we are not going inside this. So this is giving the order of n time complexity. Okay, let's convert our um, code into the memoization. Okay, so here I'm going to declare one vector. You may be aware about the vector in the C++ STL. Okay, this is a DP, right? And for this one, we slightly change this code. Okay, so over here we can write declare the vector integer dp, which is having the size we already discussed like n plus 1, but initialize with the minus 1. Okay, then we are going to call the fib util. So over here I will send the n and the dp, which is this vector. So why I have created one more function, just because I need to send this dp function in the inline. So we can, the one way is like you can create it in the like as a global variable, but the base coding practices we can send it through like this. Okay, okay. So we will change this one. Like, this will be like integer n, and we can use this dp over here. Okay, so how we can convert these things, like whenever you are finding the the dp code, we can like we can change over here dp of n is equal to function of n, and it will return. Okay, and just one more change over here is like, if you already know about the uh, that so if it is not minus 1 dp of, then we can return only like dp of n. So these two things we need to make change over here. We need to make like favorable recursive function. Okay, and over here we are passing the dp. Okay, similarly also you can do over here also like uh, your dp of n is equal to n, so for the base case, or you can do like you can initialize the base case over here also, like dp of 0 is a 0 and dp of 1 is a 1. Okay, so in that case this will be not required because we have already initialized over here, right? So this will be the answer. So this will, if we run this code, then we will get the output. Okay, so I will line by line I will understand you the how I have written the code. So it is integer main, where we are calling the function Fibonacci function for the 100 and 10,000. Okay, so it will, this is the Fibonacci function. So this is the dp array or the vector array, and over here we are storing the values, and we have initialized it with the minus 1. So whatever the number, we are just assigning, taking size for the n plus 1. Okay, and we have initialized the base case. Okay, and for the Fibonacci util, and we will pass the n and the dp over here. So if you found out that if dp of n is not equal to minus 1, you will just return dp of n. So in the in this diagram, so in this case for the f of 3, we have already find out what will be the value of f of 3 over here. So there will be no need of the recalculate these things because it is already present over here. So we can reuse this one for our output. Okay, and how we can find out like dp of n, we can call the n, so Fibonacci util for the n minus 1 and n minus 2, right? So this is the memoization technique, and it will give you the time complexity of order of n. Okay, so let's make it like how we can change it to the tabulation method. Okay, so in the memoization, we are going from the top to bottom, right? So what we are doing here, we are passing the n, right? Then we are calculating n minus 1, n minus 2, then these things like, then for the n minus 1, how we can calculate it is like n minus 2 plus n minus 3. So this is the top-down approach. And for the tabulation one will be the bottom-up approach. Okay, so we are going to this check how we can convert this thing into the tabulation method. Okay, so for the tabulation, yeah, we make the like for the, we can store the values in the dp and same dp. Okay, and we have the base case, right? And we have to just write the one for loop. We can start from the integer I is equal to n till the n. Okay, and how we can do that? So how we can convert it into the tabulation? Like just copy this thing. Okay, so where you find out the fib util, just convert it into the DP. Okay, n minus 1. This DP is not required. Fib util with the DP n minus 2. Okay, so this will give you the result. And what will be the answer? Which will be DP of n. Okay, and now this code is not required for us. Okay, so what we have did, we have just copied this thing. We have converted fib util into DP and fib util into DP. We have keep n minus 1 and n minus 2. Okay, so this will give us the tabulation, right? I'll just comment out this code. So if you required for it for the reference. Okay, so what will be the time complexity for this thing? So this is the for loop. So this is giving the time complexity of order of n, and space complexity is also order of n. So you will ask like what will be the difference between memoization and the tabulation. So in memoization, you're also getting the time complexity as order of n. But what will be the space complexity for this thing is because we are going inside the recursion. So every time we are checking for the each of the edge. So that through because of the recursion, it will give us the order of n, plus we are using this dynamic array that is order of n plus 1 or the n we can see. Okay, but for the tabulation we are not going recursively, so this is the only space we are utilizing, which is order of n. So now you can check whether we can optimize more space over in this code or not. Okay, so here how we are calculating, right? We are going to check. Okay, we already know dp of 0, right, which is 0, dp of 1, which is 1, and then here what it is going, like checking from the 2 to n till n. So here it is dp of 2, and how we are calculating, like dp of n minus 1 and n minus 2, dp of 1 plus dp of 0. Similarly for the dp of 3, dp of 2 plus dp of 1, right? So how, so in- so looking at these expression, we can find out, like let's say for this, like this is the current, which is the result of our thing, then it will be like the previous one plus previous of previous. Let's say we had consider it as previous of one. Okay, so this is the simple means we can, instead of the whole array, we can use only three variables. So through that means our time complexity and space complexity will go to the order of one. So I'll change this code into more optimized in the space. Okay, so this is not required. We will consider as integer current. This is not initialized. This is integer previous of 1 instead of dp of 0. Okay, and similarly for the previous one, it will be 1. And how we are going to calculate, we just need to change. So this is the current, and this is previous one, this is previous of 1. Okay, and then we are returning the current, but just one thing we are missing, we have to use the value, we need to update the values of previous and previous of 1. So previous of 1 will go to the previous value will update it with the current, right? Mm. So at the end, we will our output will get in the previous value. So we can return the previous. Okay. Or for the simplicity, yeah, that's all. And I will just remove this code, or I will copy this code, right? And I'm going to write over here. So this is the final output. So you may be wondering that means why I'm not writing the code in the Visual Studio or any application like that, because you need to practice it into the like normal document or notepad, because it will not give you the suggestion automatic suggestions. And if you are okay with your code, then you can just paste it into any means. For example, I am using the Visual Studio to check the code, so this is also not required, so I will just copy this thing. Okay, I'll just copy over here, and yeah, we can just run these things. So this is the best practice to means work on. Like you can run means write your code in the notepad and then just copy paste into the Visual Studio code and then check that with okay. 5 will be 5 and it will be 55 tenth. So for any larger number you can write yeah, this will give the time complexity of order of n and space complexity of order of 1. So this is most optimized code you can see over here. Thank you.